Okay, superb. Well, we're down to our second last talk, Blockchain 101, getting started. So if you're really itching to get into Web3 and blockchain design and projects, this is a really good panel for that. So it's my pleasure to introduce Mahesh Sashital and Tom Rush Mahesh is the founder and president of the Houston Blockchain Alliance and Lacrisma, and Tom Rush is here representing BlockHat.
All right, so we're going to talk about blockchain basics, and I mean basic. So if you're confused or you read things and it's confusing, hopefully we'll clear all this confusion up right now. So I guess you and I I'll do my version of it. Yeah, you can do your version of it, okay?
Yeah.
So what is it? What is a blockchain? It's just a ledger. It's a ledgering system for writing things down. So there's ledgers everywhere. You have ledgers within your company. Your bank has a ledger that tells you how much money is in it. Blockchain is a ledgering system that exists. It's just what makes it better than a database, or at least different than a database, is it's distributed. So it's the ledger that exists between big entities. So you write things down. It's cryptographically secure, meaning it's functionally immutable, and it records things between entities so that they can trust it. If something happens, the data indicates, okay, it's true, write it to the chain. Then this circumvents the proofing, 45 days to pay, due diligence, all of the things that companies do in order to stay coordinated with each other or trust, okay, I can pay that bill. I got the invoice, I proofed it, I went over it, 45 days went by, but now I can pay it. So what blockchain does is it's a ledgering system that exists between entities. Does that seem fair to you?
Yeah, absolutely. That is exactly right. And one of the key features of blockchain is the immutability aspect of it, right? So once you write something to a blockchain, you have to have consensus of more than half the participants to actually make any changes to the system itself. So if you've got a small number of nodes on a blockchain, nodes are essentially, they're the software that runs the actual blockchain itself. So each node will run a copy of the entire ledger that Tom was talking about. So a Bitcoin blockchain has probably, I don't know what the latest is, but it's like hundreds of thousands, if not millions of nodes that are running the actual blockchain. Whereas there might be other blockchains where the numbers might be far fewer. They might be in their hundreds, it might be in their thousands. And in some cases on the enterprise side, those might just be in a handful, or it might be 10, 15, 20, whatever the numbers are. But a majority of them, that means 51%, have to agree to make any change to what's already in the ledger. So that is a key feature of the blockchain as well.
Yeah, that's the part that makes it immutable, the way you have to reach consensus to write to it. Okay, so fine, great, it's a ledger. Well, what does it do? In an earlier panel that you were on, the panelists were discussing Web 1, 2, and 3. And Web 3 is where blockchains are. It's referred to as the transactional internet. So what does that mean? Well, you think about what the first web did. So it created abundance. I publish stuff out to this website, and then anybody in the world can see it. Infinite number of copies can be made, and people can download and read it, right? So that's Web point 1, the write internet. I write it out and everybody can see it. And that was, I used to sell advertising, and that was tremendously destructive if you were a newspaper company, or you were a phone book, or you ran classified ads. And then when you added video on top of that, well, that was very destructive if you were Blockbuster, or you were any television network, because suddenly, or you were a university. All you had was a stranglehold on information, and now information, was made very abundant and everywhere. So that's Web 1.0. Web 2.0 is essentially the one we live in right now. It's social media, so it's read and write. So I am not even a programmer. I can publish stuff out, and I can restrict it to who can see it, just to my friends, and that's creating enormous changes to all kinds of things, including of all things like celebrities, people that they're not in movies or on TV shows, but they're famous because they're influencers, they're on the internet, or they're on social media. So if that's 1 and 2, and it's based on abundance, this is the way one of our founders describes 3. It is the internet of scarcity because it creates one. There is one record of this. This is the NFT, the non-fungible token, or this is the conclusion from some business process, and it's written down right here, and this is it. This is the truth. This is what got written, and there are no others. And so that's why it's referred to as transactional. If I was to give Mahesh here a $20 bill, he'd have it and I would not, and that would be the truth we would live with. So if I'm going to do something transactional, it's very important that there's scarcity. I don't have it, he does, or that some business process that's working itself out, when it's done, it gets written here and there is no need to go ruminating over it more and more, look at the paperwork, go back, wait 45 days. You're not gonna know any more on the 45th day than you knew on the first day if you created that instance, that truth, right there based on the data. So it is the internet of scarcity, and that's what allows transactions to go forward. Does that seem fair to you?
Yeah, absolutely. What it does is essentially what Tom just talked about, right? So allow people to actually write to the chain, and it's the scarcity aspect of it is quite important, especially on public blockchains. But the idea is that it's not everybody that can write to it, especially if it's a permissioned blockchain, and we'll get into a little bit of that in just a little bit. So the scarcity aspect is definitely something that's very important.
Yeah. Okay, so why is this important? Well, I'll give you my impression of why it's important. I've been doing this for some time. So most of the use cases that I've worked on have been in oil and gas, and what oil and gas companies can do is just a miracle. They can go out, 100 miles out into the ocean, and they can go down in 5,000 feet of water, and they can drill a hole 2 miles underground, and then go 2 miles sideways and pull this resource up out of the ground. But when they use very advanced technology in order to do this. The drill bits, can literally be run by a guy with a stick that's on land. It's amazing what they can do. But when they get around to managing their business relationships with their vendors or getting paid from their customers, it's 1997, and that is the level of technology that they're using. So they're using an Excel spreadsheet to make calculations. It takes a team, 2 weeks just to calculate this big invoice, and then they have to convey it over to the customer, and that could, in many cases, literally be mail. Or they might email it, or they might upload it to a portal. But somehow they're going to pass through this filter. They're going to get it over, and then the people on that side are going to take another 45 days. They're going to deconstruct it, and then they're going to come back, and they're going to say, nope, that's not right. Look, it's right here in the contract. That's not right. So they are going to fight and argue over this because, and they have technology, they have databases, but it takes a long time to complete a transaction. In an environment where the data can be captured, applied via code to the contract, and then written into an immutable ledger, this circumvents that process, and it allows business to flow in an automated manner, and it makes it happen a lot faster, and it makes it happen a lot more accurately. So again, time is money, and time is important, and so if you can speed things up, it changes fundamental business relationships. That would be one use case. There are many others in which to establish something immutably is very important, like an identity. If you could make a token out of this building, so everything that's related to this building, its title, all the data associated with its architecture, every light fixture, all the income flowing in and out of it, its light bill, all the rent, then I would have a digital instance of this building, and then I could just transfer it over to somebody. That would be a sale that would not take months. I could borrow against it because I could document what it is. All of those things are possible in a blockchain-enabled environment that you think, well, that would be possible now. It would be, except that's the difference between a blockchain and a database. A blockchain is a ledger that exists between entities and documents things in an immutable manner. That doesn't exist if this company has a blockchain, or excuse me, if this company has a database and this company has a database. What they fill that space in between is time and people and the technology of ubiquity, which is what they have is, office products and email. So it's important because it facilitates transactions in a very, very transformative way. Seem about right?
Yeah, absolutely. So one thing we'll kind of keep doing is going back and forth from in the case of enterprise or private blockchains and to public blockchains. There is a lot of overlap, but there are different kinds of technologies, and the purpose, most importantly, is different. So enterprise blockchain, as the name suggests, it's primarily built for the use of oil and gas companies, medical companies, this and that and the other, right? Whereas public blockchains, as the name suggests, is completely public. It's an open ledger, which means if you want to go and see what a particular wallet has, you can go to a block explorer and you can actually put in a wallet address and you can see exactly how many assets that particular wallet actually has. It's almost like having your bank account number. You can go look up what your bank balance is. It's along those lines. You won't know who that wallet actually belongs to, but you will be able to go look up the balance on that particular wallet. So that's at a very high level, that's what the difference would be between an enterprise blockchain and a public blockchain. But why is it important for everything that Tom really just talked about? And on the public side, Bitcoin and all the other cryptocurrencies, for the most part, they are on public blockchains. And whether you like it or not, that is the way of the future. Obviously, that's something that we believe in. And we do believe that, and you can actually see it, right? Because even central banks are coming out with their own digital currencies, which are based on blockchain technology. So one way or the other, cryptocurrencies are going to be here to stay.
Yeah, agreed. Okay, so how can I get started? Well, there are many blockchain companies, and they can be divided up in a variety of ways. As Mahesh just said, there's the public ones that are built around a particular blockchain use case, which is a cryptocurrency. So it's like a dollar. It's a fiat currency meant for transferring value. So the Bitcoin network is, you can go sign up for it. It's public, and you don't need anybody's help or permission. If you're going to use a enterprise blockchain, there are various enterprise blockchain companies. I work for one, it's called BlockApps. It's not the only one, and they are all built around certain ideas. So blockchain as an industry is fairly immature relative to, say, cloud computing. But there are blockchains that are being developed that are purpose-built. So I mention this because you're going to need to engage somebody. This is not something that an entity could build on their own. And the reason is because if you did, how would it's yours. So therefore, it's like your database. You're not really going to be able to get the benefit because you don't have the trust. It's not distributed. So you can go start your own blockchain company, or you can engage an existing one. It's hard work, so I would suggest you engage one. But it has to be a company that is managing the blockchain in a distributed manner. So you think about, at least with BlockApps, it's a base level technology, and you develop an app on top of it. So you develop an app that captures data in some way, comes off of a sensor, users interact with it, it goes through the middle layer, and then ultimately it gets written down into the blockchain. So it's like any other software as a service. Data is captured, it's handed off to us, we make it immutable, apply the rules, and then it's either available or not available depending upon what the way the node network is set up. But that's generally how you get started. So again, it's a ledger, it creates scarcity, it saves time, and you engage somebody to do this for you. That's how you get all the basics taken care of. Okay, so like I said, there are many cryptocurrency networks available, of which Bitcoin is the largest and most well known. What an enterprise blockchain generally does is it's pretty simple. It just removes the cryptocurrency. So it's a ledgering system that is not meant to ledger an individual token of value. So you can capture all kinds of things into the blockchain. It can be, I've worked a lot in oil and gas where there's a lot of truck trips. So we're monitoring, picking up something over here and being dropped off over there. But in no instance are we dealing with customer funds or anything along those lines. That's essentially what most enterprise blockchains are. You want to cover like the basics of an enterprise blockchain?
I'll leave all the enterprise stuff.
Yeah, okay. All right, that's fine. So what does it do? It's an enterprise blockchain. What does it do? Well, it confirms transactions would be, like I just said, we've worked a lot in places where there is data being captured from a process to where the outcome is typically manually calculated. So if you imagine a sensor that's on a pad site somewhere out in West Texas, this data is being applied to the contract, and then a number is come up with. That's a number somebody might owe or somebody might be owed. And there's this exchange of paper in between, and then time passes by and it gets paid. So all of that can be essentially turned into a coded point and written to the chain so that all the delay is taken out of it. That's transactional certainty, be one way to describe it. So that's one potential enterprise use case. To track events would be another. So imagine you have a commodity that you're tracking through a supply chain. So there is one, blockchain created scarcity, so you have this one object, and every time the data, say, geodata, indicates that it's moving through the blockchain, that is being tracked, and therefore you don't have to rely on the shipping agent and the shipper and the carrier and the trucker. All that thing, whatever it is, that shipping container, is moving through the supply chain in a way where it's trackable and it's got a data point associated with it. So that would be another one. Many of the, I've talked to medical companies or payer-provider networks, so they're confirming identities. I have a driver's license in my pocket, came from TxDOT. That's how I confirm my identity. But they got a ledger, and I've got a little piece of plastic. Ultimately, my identity, my qualifications, my education, everything associated with me really should be on a blockchain. There's only one of me, and my identity should be captured in an immutable ledger where I can share or not share. And in the healthcare field, it is my understanding that payer-provider networks are set up in a highly manual way. So you need to document that the doctor is credentialed, he's up on his CEUs, and that is updated manually. It's literally done in the mail or via email. So identity management is a core blockchain use case. And then ultimately what you want to do is manage outcomes. So you want the real world is full of people and physical objects, and what you want to be able to do is put them into a blockchain ledger so that the outcome can be, I can show it to you, I can hide it from you. I can update it, and so at every given instance, there's a digital place that represents reality, and it's constantly being updated, and it cannot be changed to vary from that reality. So you can take the real world and turn it into a token. And why is that important? Again, this gets back to the issue of time. I've talked to a lot of construction companies, and in some cases, delay is an existential threat to these companies, because if I'm going to engage somebody to do some work for me, and they have to factor in the fact that it's going to take me 60 days to complete the business process and ultimately pay them, they're an involuntary finance entity, and I can only do business with the ones that are willing to wait, and they will factor that cost into their bid. So you can't get the best outcome if delay is a factor, and you also can't get the best outcome if, for example, the data that represents the truth cannot be shared appropriately. This becomes very important in insurance use cases, because If you have one, say, trucking firm that's highly responsible and doesn't have a bad accident record, and you have another one that has a very poor record, the insurance industry is not sophisticated enough to tell them apart. So they end up with an insurance rate that just represents the aggregate risk of the trucking sector. And with the data and an immutable record, now I, as a trucking firm, I have my reputation, I have my identity, which is unique to me, and then I can get a rate that it reflects the risk that I represent and not everybody in an aggregate. So time and accuracy is what the Internet of Scarcity is ultimately going to bring. Make sense?
So let me talk about the public blockchains. Those are the ones that we kind of talked about. They're the ones that you hear about for the most part, like Tom mentioned, there's Bitcoin, Ethereum, Polygon, so on and so forth. There's a bunch of them. So what exactly are they, and how are they different from the private enterprise blockchains? We kind of touched on that a little earlier about the accessibility of the data. But I want to kind of talk a little bit about what it is in terms of the cryptocurrency and the tokens themselves. So everything that Tom mentioned about the ledger and the data being on the blockchain and all of that stuff, all of that is still true when it comes to public blockchains. It all works the same, well, in a similar way. What is different about public blockchains from the private ones? Obviously, the private ones are actually being run by some corporations, some enterprises, and they're the ones that are actually validating that the transactions that are written to a blockchain are correct. Now, in the case of, I'm going to just take Bitcoin as an example. There's millions of transactions happening all the time, and there's millions of nodes that essentially have to agree that a transaction that's been written is actually valid. If I wanted to send 10,000 Bitcoin to Tom, somebody would have to verify that I actually own 10,000 Bitcoin. And when I do send it to him, that his wallet actually has the 10,000 Bitcoin. Somebody has to do that. Currently, when you send money through the bank, it's the bank that's actually doing this. In this case, there is no middleman. That's the whole point of blockchain. There is no middleman that's actually looking at these transactions and verifying them. The actual blockchain itself is the one that's validating all these transactions. And in the case of a public blockchain, it's the regular public that is actually doing validation. So in theory, you could go home, you could buy a machine which does Bitcoin mining. You could plug it up to your electricity, connect it to the internet, download the software for Bitcoin, and start mining Bitcoin. Mining essentially means you are validating, you're going to be one of those people who will be validating those transactions. So why would you do that? You have to have some incentive to do this, right? So that incentive is those tokens, those cryptocurrencies. So when somebody says, oh, Bitcoin is at 20,000 or 60,000 or 3,000, whatever, that is what the value is that the market assigns to for somebody when they are validating those transactions. That is what cryptocurrency actually is, and that's what Tom was talking about on the enterprise side. That does not exist because, again, these nodes are being run by enterprises, so they don't need to be incentivized to be validating those transactions. Whereas on a public blockchain, they have to be, right? So why are there so many different cryptos, right? You hear so many different ones, right? There's Dogecoin, there's this, that, and the other. So essentially what's happened, obviously Bitcoin is the original, it started about 13 years ago. The only thing that you can do on the Bitcoin blockchain, for the most part, I mean, there are some changes that's being made right now, but for the most part, Bitcoin, the only thing you could do was send a transaction from one person to another. That was the only thing that you could do. Ethereum came along about 7 or 8 years ago, and you could actually write code onto a blockchain. Now, there are some other challenges that Ethereum has that then the next one came along and said, you know what, I'm going to solve the problems that Ethereum has, and so on and so forth. And that's why you've got so many different blockchains, and each one has their own validation or their consensus mechanism, right, where they are actually validating these transactions. And because they all follow a similar pattern as Bitcoin, they all have their own individual cryptocurrency to reward those people who are actually validating these transactions. So Bitcoin has BTC, Ethereum has Ether, Cardano has ADA, blah, 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 right? So each one will then incentivize those validators for their blockchain using their native currencies. So that's why you've got so many different blockchains and so many different cryptos. Now, is it a scam? I mean, it's not, but are there scams? Yeah, for sure, there are, right? There's so many different scams, but is cryptocurrency in general a scam? No, it's not, right? Because Bitcoin has a real value to it. Now, why it has value and what is that exact value, that's a whole different conversation, right?
But you must be getting all the same questions I am from your friends about FTX, and
oh yeah,
I've tried.
absolutely.
I can't explain a lot of that. I'm not convinced that that was a scam, possibly
Absolutely
from the
it
very
was.
beginning. Like,
Absolutely.
that's just fraud from the get-go. Poor corporate control. Doesn't have anything to do with Bitcoin. That's just a poorly managed company.
Yeah. Yeah. I mean, poor management was one thing, but I think, like what you said, you know, it was an outright scam, right? It was an outright fraud, rather, not a scam. So FTX is definitely one of those, but when it comes to the actual blockchains themselves, for the most part, at least the large ones that are there, there's at last count there were like 20,000 cryptocurrencies out there. And I'd guess, you know, a bunch of them are either scams or they are not good investments or really have any real purpose. Dogecoin, as far as I'm concerned, is one of them. But in general, you know, a lot of these large ones, they're not scams themselves, right?
Yeah, and certainly the technology itself is not a scam. It's just a way to use computing technology to generate an outcome. You can organize any sort of use case on top of it or put a corporate controls on top of it or not, but the underlying technology is not a scam.
Yeah, absolutely. You know, and like what we were talking about in the morning session, right? The FTX thing was a fraud right from the beginning, and so was it was basically a lot of the challenges of having an unregulated, centralized corporation which is managing other people's money. You know, what could go wrong, right?
I think we have a question. I saw Ariel raising her hand. Are we? I believe so, because I think she's got the microphone. Okay, you want to move on to the question part?
Yeah, we can
Okay.
we can get to. We've got about 10 minutes for Q&A if there's.
Okay, perfect. All right, bring it on.
Good afternoon. I know that I learned about the blockchain maybe about 3 years ago now, and then they use it for more than just financial benefit. Do you find that you use it, like people are selling art on blockchains now and they're doing those things? Do you see that the wave in the hospital systems or the healthcare systems will be going to marketing products that can be bought completely on blockchain?
Yeah, I mean, part of the concept of pumps and pipes was about the relationship between oil and gas and healthcare. They're the number one and number two employers in Houston. And so that's kind of how this all came about. So because most of my experience has been in oil and gas, whenever I speak to people in healthcare, usually that's what I'm looking for, is where the overlap is, and it's there. So, for example, I was talking to somebody from Methodist, and they were telling me how, you know, they'll position cameras in where there's an operating theater, and then they can tell where people are standing and what tools are available, as to what's going on. And that's exactly what they do on oil platforms. They'll put like a little LiDAR system out there, and it can tell based on where people are standing what they're doing. And they can tell when it's about to go to an unsafe place. If they're performing a certain function, well, nobody should be on that tower. So within these two entities, there's many, many overlaps in terms of what their priorities are. And there's also, by the way, serious data privacy concern issues. I've heard it a million times. So there's, patient data and there's transactional data, and you can't mix the two. But yeah, hospital technology is essentially data related to a function that either needs to be seen or not seen depending upon the rules. And a blockchain is a way to impose rules on data and then put it in an immutable ledger. Does that answer your question? Okay. I think there's somebody over here. Let's get a gentleman with his hand up.
Hi, I think it's been pretty well established that proof of work is not a very good, that doesn't scale as a reward for mining, developing the consensus. Proof of
Stake.
Stake, yes, having a stake, being a stakeholder, that's been tried and seems to have some problems. Is there any consensus process that looks over the horizon that may scale as would be necessary for our population and the size of the blockchain?
Proof of stake is working as far as I know. I mean, it's less energy intensive than proof of work, but it does establish a distributed consensus mechanism. So it solves the problem of, you don't want, what they refer to as a 51% attack. So 51% of the consensus mechanism is going to be taken over by, one entity, a Russian hacker, and then they can control what gets written into the chain. So proof of work is a way, proof of stake is a way to say the validators are stakeholders and they're distributed in far and wide enough so that you can address the 51% problem. In Ethereum, went from proof of work to proof of stake fairly recently, and I believe it's working, as far as I know, it's working fine. What do you think?
Yeah, so proof of work is basically spending energy. So that's how Bitcoin works. That's where it originally started. It's basically spending energy to prove that you've actually done the work so going back to what I was saying earlier about the number of nodes that are out there, right? So out of those millions of nodes, only one node gets picked by the blockchain algorithm to actually solve the problem of validating all the transactions in a block, right? So I don't want to get too much into the technical details of it, but essentially what's happening is that when these nodes get picked based on a problem that is solved, that they solve. And I'm now speaking specifically about proof of work and Bitcoin. And the problem that is solved is just solved by essentially spending electricity. It's just burning electricity. That's the proof of work. And when they actually solve it, that particular node is rewarded with 6.25 Bitcoin. That happens every 10 minutes. And 6.25 Bitcoin, even at these low numbers, is still a significant amount of money that you can earn every 10 minutes, right? So that's what's about almost $100,000, right? So that's what the proof of work is. Now, proof of stake is when you are actually staking your tokens or your coins or whatever, right? So essentially, the difference between the proof of stake and the proof of work, for the most part right now, is the concept of scalability. So scalability increases when you move from proof of work to proof of stake. But at the same time, it becomes a little less decentralized. With proof of work, you can have millions of nodes that are actually running this, whereas with proof of stake, you have to have a certain amount of money that you actually stake, a certain number of coins. So that is the biggest difference between the two. But to your point, I guess the question about is there something on the horizon? I mean, there's many, many different kinds of consensus mechanisms, but these are the two biggest ones that are being used. And for the most part, they seem to be working. None of them are perfect, and which is why you have so many of them.
Yeah, one additional point about that. So as we noted before, one of the differences between a public and a private blockchain is the validators. And so BlockApps is Ethereum-based, meaning it uses the Solidity language and it uses Ethereum protocols to reach consensus, and there are governance tokens that are distributed. But if you're one of our customers, it's our promise to you that the validators will be, it's not under our control, and there is no way for the control of our network to fall under nefarious actors, or so anyone could get more than 50% control, and then they can determine who writes to the chain. But proof of stake, for the most part, solves the energy problem, especially as it relates to Bitcoin. If you've ever been in the room with a Bitcoin miner, it sounds like a leaf blower, because that's how much energy it consumes. And proof of stake lowers the amount of energy it takes to validate the blocks on a network by many, many fold. And I hope that answers your question. But is there another mechanism on the horizon? There was proof of work, proof of stake, not that I know of.
So there's a couple others. There's proof of elapsed time, there's proof of history, there's a whole bunch of them. But none of them are as prevalent as proof of work and proof of stake.
Well, plus there's the issue is it can't be distributed. Either you're working on something or you have a stake in something. I don't know under any other circumstance in which case you could distribute the work. Like, you have to motivate people to do this. The bank that's got your ledger doesn't need to motivate anybody to keep that ledger up to date. It's their ledger and this is their job. So if you're going to have a distributed ledger, you have to motivate the network in order to participate. Governance tokens or just awarding them a little piece of Bitcoin is how these things are operated. I've not run into another way to do it. Maybe there is, I don't know. All right, we got about a minute.
I guess the one last
There's
question.
one guy, yeah.
Just had a question whether or not there's a risk if you pick a blockchain to accidentally picked Betamax instead of VHS or something, where you can wind up with your data locked up or messed up. Is that a risk?
Yeah, I think it's a risk if the company fails and you can't retrieve your data, if you were very reliant on that data. So there's that risk. It's just the failure of the company. If their mechanism was not well designed, then maybe you would have a cyber risk of people getting into it. So yeah, there's a risk. You need to make sure you're doing business with reputable actors. But I think that at least in an enterprise blockchain, that's all your risk, because we're not like FTX. We're not, in no enterprise blockchain that I'm aware of, are they taking custody of customer funds. So you wouldn't lose your money. The risk is to your data, which is that's a big risk. But it would not be to your money.
And that is all the time we have. So
Yeah, that's it.
thank you, everybody.